Hello everyone. So, my name is Shreya and today we are going to study a very important topic of your chapter Haloalkanes and Haloarenes, which is a nucleophilic substitution reaction of alkyl halide. So, have you heard about the nucleophile? Do you know what is nucleophile? What is substitution? What is alkyl halide? You all know this, right? So, what is nucleophile? An electron-rich species is known as nucleophile. Any species which have the negative charge or which has the lone pair, so that species is known as a nucleophile. For example, OH negative, okay, F negative. So these all are nucleophile. What is alkyl halide? When carbon makes bond with the halogen, or the general representation of alkyl halide is Rx. So this is the alkyl halide where X, जहाँ X क्या होता है? Where X is halogen, fluorine, chlorine, bromine, iodine, anything it could be. Okay. So great. So nucleophilic substitution reaction. So first of all, we will see the basic step of this reaction. So what happens? As you can see, there is a bond between the carbon and the halogen in alkyl halide. So Rx bond is polar in nature, right? So this bond is polar in nature. As you know, X halogen is more electronegative then R, then carbon. So it pulls the electron towards itself. It pulls the electron towards itself, and that's why this bond is polar because R will acquire the partial positive charge and X will acquire the partial negative charge. Right? Great. So for that reason, this bond can be broken and the nucleophile can attack and can be attached to R. So what is a basic step? एक basic step क्या होगा कि R X, and for example if you take a nucleophile you will get R N U and X negative. So nucleophile has occupied the position of X and X has left. X ने तो छोड़ के चला गया है वो तो ठीक है. So there are the two methods or the two mechanisms by which this nucleophilic substitution can happen. What are those two methods? The first method is SN1 and the second method is SN2, right? SN1 and SN2. Great. So we will study one by one. In today's lecture, we will cover about the SN1 mechanisms. Okay, so both have in both mechanism nucleophilic substitution reaction takes place, but the process, the steps are different, right? Okay, so now we will move forward to the SN1 reaction. So what does SN1 reaction means here, or SN1 mechanism means here? So S means substitution, of course. Okay, substitution, of course. N means nucleophilic and 1 means unimolecular. So what is unimolecular? We will study it. So what happens in the SN1 reaction? There are the two basic steps. In the first step, we take alkyl halide, or you can say substrate here, and the bond will break due to its polar nature, and we will get the R positive. Both electron will shift it to the X and we will get R positive and X negative. So you know that R positive or the carbon having the positive charge is known as a carbocation. So formation of intermediate takes place here. In the second step, what happens? The carbocation will further undergo the in the reaction. Nucleophile will attack on the positive charge, and you will get your final product RNU plus only RNU here, right? Okay. So as you can see, this step is a slow step because formation of intermediate is taking place, or you can say this bond is breaking here. This is a slow step and we can say rate determining step here. And this will determine the rate law, or this will determine the rate of the overall reaction. So as you can see, in the rate determining step, only one species is involved. That's why this is known as the unimolecular. Clear? Why we call it as unimolecular? Right. Now we will study about the more properties, more characteristics of the SN1 reaction. So the first, you can see the rate depends on only on alkyl halides concentration or the substrate concentration. So you can see here the order is 1. Order is 1 here. Right. So, have you studied about the orders of reaction? Have you studied about the chemical kinetics? Of course, you have studied. And in chemical kinetics, you have seen there are the different orders, zero order, first order, second order. Here, the SN1 reaction is of first order, and I have told you why. Okay. So, because Rx has a power 1, that's why order is 1. Right. Now, the second thing about the solvent, here we use polar protic solvent. As you know, every reaction takes place in some particular solvent. So polar protic solvent we used here. For example, polar protic means any solvent which is polar in nature, which has a polar bonds and which has a H plus to donate. For example, H2O. Right. So we use polar protic solvent here. The third thing is, if we see they we know that there are the different type of alkyl halide, 1 degree, 2 degree, 3 degree, right? So the rate of reacting of alkyl halide is this: 3 degree will react more faster, 2 degree less, and 1 degree not show does not show SN1 reaction, because as you know, 3 degree carbocation is more stable than 2 degree, and 2 degree is more stable than 1 degree. So as you know, carbocation is forming, the more the stability of the carbocation, more will be the rate of the reaction. So third point is very important here. Right. Okay. The fourth thing is, if we discuss about the stereochemistry of this reaction, so student, as you can see here, the formation of carbocation takes place, and you know carbocation is planar. It is planar. It has a planar geometry, right? So it has the planar geometry. So nucleophile can attack from both sides. It can attack from the upwards, it can attack from the downwards. Both possibilities are there, and that's why we will have racemization here. Like 50% R and 50% S product. For example, let's take an example here. You will understand better. If we take a tertiary alkyl halide, for example, this one, CH3, as you can see here, the carbon is attached to the three methyl groups, and this carbon is attached to the bromine. That's why this is 3 degree alkyl halide. And if you take any nucleophile, but in the first step, we will not take nucleophile, right? In the SN1, there's the two-step process now. So the bond will break, and we will get carbocation first. And in the second step, what will happen? The nucleophile, uh, if we will take this in the second step, what will happen? The nucleophile, for example, OH negative, it can attack from here, it can attack from here. Okay, if you take this plane, for example, this is plane, so it can attack from above the plane, it can attack from below the plane. Both are possibilities. And for example, this alkyl halide has a configuration R, but this is not optically active. But if we take any optically active alkyl halide, so we will get the both R also and S also as a product. So racemization will happen here. So if somebody asked about the stereochemistry of the particular mechanism, you can definitely told him or her that this reaction shows a racemization. We will get the equal amount of the enantiomers, but we call it as racemization or the racemized product. Clear? So these are the basics of the SN1 mechanism. I hope you understood this. Okay, so great. So In the next lecture, we will study about the SN2 mechanism, students. Thank you for watching. Take care.